All right, good morning, everyone, and thank you for taking time out of your busy schedules to be a part of our webinar entitled Recycling Equipment Innovation, Advanced Robotic Technology. I know it's a rainy Tuesday morning. Hope everyone's staying dry where you're at. I know there's some flood warnings and everything that are happening, so hopefully everyone's staying dry and everything's running smoothly with your facilities. This webinar is being put on by the Tennessee Recycling Coalition in collaboration with the Tennessee Department of Environment and Conservation and A&P Robotics. My name is Caleb Powell, and I'm an environmental scientist for the Office of Policy and Sustainable Practices at TDEC, and also a current board member for TRC, the Tennessee Recycling Coalition, and I'll be hosting the webinar today for our wonderful speaker. And then TRC's plan is to have these type of webinars throughout the year to bring new innovations for recycling and just new ideas to the recycling sector. So we hope you guys get a lot out of it. I'm very excited for this webinar today. There's a lot of research that I've done sort of about advanced robotic technology and recycling. So very excited to see the cutting edge technology that is advanced robotics. Everyone is muted upon entry to reduce the amount of background noise, but if you have any questions, comments, or concerns, please feel free to ask them in the chat. I'm going to go ahead and send a chat message to everyone. So you should be seeing that. There's a drop-down box that can specify who you want to send that to. If you're sending a question, make sure that it's either going to all participants or all panelists or just the host if you want it to just go to me. Then I will work on getting those answered to our wonderful speaker. Tim also wanted me to let everyone know that feel free to ask those questions. You don't have to wait to the very end. Feel free to ask those questions as they come up so you don't forget them. He said that it works best being sort of a discussion, so excited about that today. There also is a little hand emoji. You can raise your hand if you'd like to actually physically ask your question yourself. So I will be looking over all of the participants, and if I see your little hand emoji, I'll unmute you and you can ask your question yourself, and you don't have to have me ask that question for you. So just to give an overview of what we're going to be covering today, in this webinar we'll be learning about integrating artificial intelligence and robotics into the recycling sector. Intelligent robotic systems are new tools used to meet the essential needs of today's recycling operations. AI and machine learning enable robotic sorting of material as granular as a type of plastic at a pick rate of upwards of 80 items per minute, twice as fast as human sorting, and with greater accuracy and consistency. So also when data is captured, it provides transparency to recyclers so they can optimize their operations, increase recycling rates, and economically process the feedstock needed so manufacturers of packaging, containers, and other goods can meet goals for recycled content and achieve society's vision for a sustainable circular economy. So with that being said, I would like to introduce our speaker, Tim Berry. He is the Midwest Business Development Manager for A&P Robotics. Super excited to have you, Tim, and I will pass it over to you now.
Perfect. Thank you, Caleb. Can everybody hear me first and foremost?
Yes, sir. Loud and clear.
Perfect. Great. Well, happy to be here, guys. Thank you very much for the opportunity to talk to you today about robotics and AI and how we use the two together to give you guys a more economical way to do sorting, help with labor challenges, increase pick rates, all of those things in your facilities that you're looking to do and capture today to make recycling as a whole more economical. So I'm Tim Berry from AMP Robotics. I cover Central U.S. and Canada, and happy to be here today. So go ahead, Caleb, let's get started. So all of you, not showing you anything here that you guys already don't know, but the MRFs across the country are seeing challenges recently more due to types of labor and things like that. In order to bring in labor, maybe having to pay a higher wage, all of these things leading up to the fact that if we can't capture labor or we're paying more for the labor, we're losing more commodities to residue and or having to pay more for that labor to capture the commodity. And what that boils down to is the erosion of the value of the recyclables due to all the high costs, whether those high costs are more labor or dropping in, having to constantly add new equipment to the facility over time. But there's a tremendous amount of manual labor from pre-sort to residue lines to container lines, everything that you guys are familiar with, and that's where we're trying to step in and give you guys an automated solution that's going to recognize equipment, recognize commodities like a human would, and be able to pick them faster than a human would to give you increased performance and something you can count on every day, 24/7. We have some people running them post-shift, like after everybody goes home. They have surge bunkers and things like that, and they can run robots when nobody's in the building. So lots of things that we can do with this. Go ahead, Caleb, on to the next one. So our mission as a whole, as you can see there, we're looking to enable a world without waste. And while everybody wants to be there, there's obviously a number of challenges to get there. Most importantly, we think, is making it more economical to do so that you have more people wanting to do it, more people wanting to capture those recyclables because it's not as challenging and they're making more money. It's more economical to do so. Therefore, they're more likely to do it. So we've made it our mission to develop, cutting-edge technology to drive down the cost of the sortation and provide the tools to improve the efficiencies and elevate those recovery rates. This is all kind of made possible by using data-driven approaches and automation of certain key elements within the facility. Go ahead. So at a glance, this is us. We were founded in 2014. We are headquartered just outside of Denver, Colorado, and 250 plus employees, growing very rapidly. Full production with systems in the U.S., Canada, Europe, and now Japan. We've been able to put robotics in Japan, which is big for anybody who's aware of Japanese and their technology. We've been able to get in there, and a lot of people over there find what we're doing very compelling. We are in 25 plus states, as you can. I think we're closer to 30 plus states now, actually. And the way this goes in is, we can basically drop our stuff in over your existing equipment with just a few modifications. It's not a massive retrofit where you're going to be down for days or weeks at a time to get it done. So we have over 200 systems deployed globally, and we are recognizing over 10 billion items with our AI on an annual basis. And that will, that 10 billion item number will come back and mean a little bit more as we start talking about the AI. But this is the industry's largest real-world data set of recyclables for machine learning. And that's what really sets us apart from anybody else out there, is the AI and how we're feeding that AI. So that 10 billion number, we'll come back to that, but something to keep in mind and or to discuss with anybody that you're looking at robotics with moving forward. And talking about, why we do this, trying to reduce waste, emissions. As you can see there, the metric tons of greenhouse gases that have been eliminated with our systems is large and continues to grow. So as we can implement more automation and stuff like this and recover more of these commodities in the recycling industry, what that curve looks like is an exponential curve, right? It's not so much linear. So the more of this we can do in the industry, the more rapid that saving of those, or the elimination of those greenhouse gases becomes. So what we have here is a quick video of what our robots look like in a facility, just to give you all a kind of point of reference for what they look like, how they fit in there, what they do, and what their capabilities are. Thanks. Thanks for that, Caleb. So that is one of our customers in Sarasota, Florida. They actually have 14 robots working in that facility there, very large facility. This is the single largest deployment of robotics for recycling in the entire world, to have 14 units in one location. Systems in there, I believe you saw, we're working on fiber lines, we're working on container lines, we're working on QC lines, and we have a robot or two on the residue line, just grabbing whatever we can before that goes out the door. As Caleb mentioned at the top, these robots are sorting, doing at least 80 picks a minute. Some of them are doing, 90, approaching 100. All of that kind of depends on material presentation, how much material is being presented to the robot, how much of that it can recognize and go after. The accuracy that those robots are working with are upwards of 98%. Therefore, the bale purity and stuff that those robots are creating is extremely high, which makes, resale that much easier and or getting more money for your resale of those commodities that much easier. You saw there were some humans in front and or behind the robots at this facility. That's more of they're picking out there to make sure any big, large pieces of material don't get into the robot, or if there was something that the robot missed coming out, they have somebody there at this facility to do a little bit of QC, but largely the robot's doing the majority of the sorting at the facility. So this is our robot. So with these robots, we have essentially three pieces to them. The AMP neuron is our AI system. That's the brain. That is the thing capturing and seeing and storing those 10 billion images a year. And with those 10 billion images a year, that's building up essentially a database. And we've been building that database for longer than anybody in the industry. And with every new robot or vision system that goes out into the field, that number continues to grow. So everything that gets put out, if it's a unit in Canada or California or in Europe, anything that they're seeing is all getting fed back to the database and then pushed back out to everything in the field. So your robots in Tennessee benefit from robots in Florida and California and Texas and New York and New Jersey. So if, for example, Coca-Cola or somebody like that were to release a new bottle, the robots on the coasts in New York and California, wherever they release it first, would see it, learn it, and by the time that bottle started coming across the lines here in the Midwest, our robot already knows what it is and is going to pick it for you, as opposed to not knowing what it is or not knowing what the plastic type is and mis-sorting it. The robot's going to be on top of that. The Cortex itself is the actual arm within the frame. That is a unit built by a company called Omron. They are the leader in the industry for robotics. We've partnered with them and we use their unit within our system. It's proven to be the best, and if we're going to put the best product out there, we need to work with the best people. Our vision and clarity system. The vision system is the small cabinet you see on the line just ahead of the yellow cage. And what that is a camera system, a series of lights and cameras in there that allow us to classify, see and classify everything as it's coming down the line in real time. Just say what type of plastic it is, what type of fiber it is, if it's colored, non-colored. We can classify and sort to all those things and then therefore pick based on all those things on the backside. So that's the vision system. The clarity piece of that is the data that comes from that. So vision allows us to see it. It sends the information to the neuron to say, hey, here's what it is. The neuron sends that signal to the cortex to say, pick it off the belt. The clarity piece is putting all of that into a dashboard so that you can see it on a tablet, a computer screen, a phone to see how your facility is running on a day-to-day basis, telling you if you're getting an influx of fiber or things coming through the facility because you may be pushing wet material today and the screens aren't doing great and need to be adjusted. It allows you to see day-to-day based on different haulers or people bringing in material. If it's more commercial, more residential, allows you to get a breakdown of what's running down your belt, what you're seeing. We have a lot of people putting this type of vision technology on the residue line to see what they're losing, to see what sort of upstream, additions or changes can be made to start capturing that material better. Sometimes it's a robot, sometimes it's changing the pitch on your screen, sometimes it's, making adjustments to your opticals, whatever, but it gives you data to make informed decisions based on material flow for that day or for that hauler or for the weather conditions or whatever, but allows you to fine tune your facility based on what you're seeing, and instead of just setting it and forgetting it or making an educated guess, you actually have data to work off of. And then the AMP materials piece we'll get to at the end. That is a new part of our business where we're leveraging our technology to do secondary sorts. So all that stuff that is going out the door right now from you guys to landfill, we're trying to capture that, run it again through our technology in some of our facilities and pull out the commodities that were missed the first time through. So walk you through this a little bit, but this is hopefully a little bit easier way to understand it. Like we said, the vision system, the eyes, the camera, the lights up front, sees an image, digitizes it, sends it to the brain to be able to store it, grow our database, and communicate what needs to be picked to the arms, to the Cortex unit. It's going to go and pick it, throw it in the bin, and then what you see on your Clarity dashboard is what went down your belt. And we are getting to the point now of being able to give you pick success metrics. So it's going to tell you, here's what was on your belt, here's what was eligible, here's what we picked successfully, so you know exactly, how successful your robot is being and what's being picked off of your line for you. Get the next slide. There we go. So modernizing existing facilities. So what we have in this picture in the background, like I talked about, it is a retrofit of sorts, but it's more a plug and play type of retrofit. So our robots go in typically over a weekend. There are some facilities that are 24/7. Most people shut down on the weekends. We typically come in on a Friday afternoon when you guys shut down. You can see there, we fly it up there, we set it in place, do all of our work over the weekend, get it fired up and rolling so that Monday when you guys come back in with the lights on and get everything up and rolling, this is in place. You haven't lost any downtime. Upon Monday coming in, we'll train everybody, get everything up and rolling, make sure it's operating to agreed upon specifications, and get everybody trained up before we leave the facility. But this is, just a snapshot of what this looks like. Drops right in over an existing line. There may be some shoot work or some things like that just to make sure that we have places to throw the material. But for the most part, significantly less invasive than other retrofits or other pieces of equipment that go into your facility. So we're at Cortex. We can do anywhere from 80 to 120 picks a minute. Actually, those are kind of baseline numbers. The big range there is we have two different options. So in the picture there, you see a robot with two arms inside. The robots with two arms are placed over belts over 4 feet wide. And that's due to the fact that those robot arms have a set kick radius. Okay, they can only move so far. And if a belt is wider than its pick radius, it won't be able to cover the whole belt. So anything over 4 feet requires two arms. You know, the front arm in this case would work the left side of the belt. The back arm in this picture would work the right side of the belt. Therefore, you get full belt coverage with each robot arm doing half the belt. You have two robots working in the cage. That's where we're seeing picks, 120, upwards of 120. If you have a belt narrower than 4 feet, most belts, on containerized, things like that, are your 30 to 36-inch belts. That would have one arm over it, and those robots are doing, 80, 85, 90 picks a minute. Over the manual sortation, the industry standard there is 40 picks a minute. So upwards of, twice as many picks a minute versus a human. Like I said, we are 99% accurate in our object recognition and 78% lower in cost. So a lot of times when we put these in, we're replacing or filling the spot of, a handful, 2, 3 humans, that you may have already, and you want to reallocate to pre-sort or move someplace else in the facility, or in a lot of cases recently, we've been putting these in places that have just been missing sorters in the facility. And, they want to capture that material and they don't have a warm body to do it. And a lot of times we're seeing ROIs in that case with, less than 3 years, sometimes less than 2 years, depending on how many shifts they're running. So it is a big, piece of equipment. It is a big investment. But based on the number of picks that we can run with this thing and what you're going to be getting out of it, we typically see a very favorable ROI. So just a kind of high-level understanding of real-world how this works. We sort plastics down to the 1 through 7s. In 1s, we can go into blues, clears, greens. With the polypropylenes, we can work on food grade versus non-food grade. On the PETs, we can also do thermoforms versus non-thermoforms. So there are all sorts of sub-labels and categories that our robot is capable of recognizing, that sometimes it's even harder for humans to distinguish when it comes to things that may look very similar, if it's polypropylene or HD. When it comes down to polypropylene, is it food grade, is it non-food grade? Our robot has some very significant advantages in some cases over sorting things correctly, that if you have a human, and maybe the human's been in that spot for a while, they have it pretty well dialed in, but especially with turnover, to get the type of performance and consistency that you get from a robot, very hard to do with a human, with some of the things that are a little bit harder to distinguish between. So next slide. So real world examples, yep, with the polypropylene, it's typically been very challenging to recover, hard to distinguish for, the human sorter on the line. And, therefore it's been missed, and now there's a lot of push for this. Clear polypropylene, food grade polypropylene, all sorts of grants now trying to drive the funding and the interest of trying to capture this stuff. And it's something that, our robots are actually very good at. So go ahead, next slide. Real world example of this, we've actually worked with Keurig Dr. Pepper, with all these K-Cup pods. They changed their K-Cup pods to polypropylene because before they weren't a recyclable plastics. Now they changed them to polypropylene and work with us so that we can now we developed a custom label for them so that we can recognize and pull those things off of the belts. But we're doing this type of work with all sorts of producers across the industry. This is just one example of it. And as things are changing, or as people are changing the packaging types, the packaging plastics, we're getting out there and getting ahead of that with our robotics, so that when those things come down the line in the facilities, we're sorting them appropriately, putting them near bales to increase bale purity or decrease contamination, either way you look at it, and be able to do it at a consistent, repeatable process where, again, training a new human or the human guessing correctly is a bit more of a shot in the dark. So next slide.
Hey, Tim, we actually had a question come in. So I wanted to go ahead and do that since we're sort of in the that point. So the question is, do the AMP robotics system, does it use a type of infrared sorter, or how the question basically is how is the machine able to determine the differences in like food grade and other types of plastics?
Yes. So we use an AI as a camera system, high def camera, and it's not near infrared. It's not like what your opticals are using. So this is form factor. So the easiest way to explain deep learning with AI is essentially we give the AI a handful of pictures of things in the beginning and say, hey, you know what? Here's a picture of a K cup. This is a K cup. This is polypropylene, and we give it a handful of those pictures, you know, from all different sides, and then we crumple it a couple different ways and give it more pictures of that, and then we say, okay, now learn from this. So it takes this and it creates a ton of data points around it, and then as everything comes down your belt, the best way to kind of explain it is if it sees something that meets, you know, a whole bunch of the same data points, it goes, yeah, that's a K cup. It may be a K cup, but it's crunched a little differently than we presented it. So it takes that and goes, there's enough data points on that for me to know that it's a K cup. It's not exactly what I've seen before, but it's a K cup. So I'm going to go grab it. But now it also sees that K cup kind of crunched in a new form, a new way, and it adds that to the database. So that's one of the 10 billion data points a year. So we teach it something, you know, just like you would teach a human something. You give them the basics, and then they start to understand it and grow on it and further develop it on their own. Same type of thing with this artificial intelligence, and that's why it's artificial intelligence. You give it something to start with, and then it goes, okay, yeah, this is like that, so it is that, and then we start building those things out. And as it keeps adding those new images of these things, whether it's PET bottles, K-cups, you know, 2-liter bottles, milk jugs, whatever, now we've essentially seen PET bottles presented in any way you can imagine them, crunched, flattened, you know, twisted, cut in half. You know what I mean? There's so many of these data points now. We're seeing 10 billion of these things a year that it's learned much like a human would that, you know, that PET bottle, that water bottle doesn't look like it did when I bought it from the store, but I know it's a water bottle because I've seen it so many different ways and it meets so many data points that I know what it is. And now I've built a huge database to say, yeah, I've seen one that looks almost identical to that. I know exactly what it is. So does that kind of answer the question there?
Yeah, I think definitely. There was another one that sort of came in that said, is each like retrofit or each machine that you put into a facility, is it having to be taught these data points itself, or does it already have those built in?
Already built in. So like I said, we're over 200 of these in the field. So that's another difference between us and some competitors out there is they'll say, hey, well, you know, we'll drop a camera system in for a month. We'll learn exactly what's coming through your facility, and then we'll upload that into your robot, and your robot will be great in your facility. Well, you know, that 30-day snapshot of what ran through your facility may or may not be what's going to continue to run through your facility, and or you know, may not capture everything that typically runs through your facility. So essentially, when a robot goes in, it's armed from day one with the database of all 200 robots, 200 plus robots in the fleet. So everything that we've seen at any robot around the world, you have the benefit of the day this thing goes in. That being said, if there is something in your specific facility that we've never seen before, case in point, we did a install at Michigan State University. On their campus, they have a small MRF. At their facility, they have big juice containers in their cafeterias. And what goes into those juice containers is almost like a giant printer cartridge full of orange juice made out of HDPE. We don't see that at single-stream MRFs typically because that's not sold in the grocery store. We don't put that in our blue bins on the curb. So we didn't have data points for that. That like went down the belt and we said, our robot said, I have no idea what that is. So it got missed at the MRF and they said, hey, we needed to pick that. And we said, okay, cool. Send us some pictures. We uploaded it. We said, you know, if you have some on site, can you run those into the camera so that we can kind of see them in real time, you know, crunched and whatever, how they come in. And we were able to push those up into the database now. And now the robot is picking those things. And now with everyone that comes through that facility, crunched or bent or whatever, a slightly different way, it's going to be adding, you know, another image into that database for these giant HDPE orange juice cartridges. So it does take a couple weeks to add a brand new product like that and get enough images where the robot is really starting to be able to build its own intelligence on it. But if it's something specific that you need done at your facility that we haven't, then there's not a lot of that, right? Because we have so many of these across the world that we typically have seen almost everything. But if it comes up, we can do it and give it the early ideas of what it needs to know, and then it can start developing that learning.
Awesome, thanks for that.
So last piece here. This is a snapshot in the background of how the robot sees material going down the belt. So you can see these boxes, everything around. It'll put a box around it and it'll label it. So you see, you know, just to the right of the center there, you see fiber, you know, you see metal, aluminum, UBC. So this is how the camera, as your belt's moving in real time, and our system can operate on a belt working up to 300 feet per second. So this is happening instantaneously almost. But you see there's one tiny little K-cup up in the upper left corner with a brown box around it that says plastic, polypropylene. And because of our system, you know, who knows if a human would have seen that tiny little plastic polypropylene up there. But this robot is set to pick polypropylene and other plastics. So it was able to see that and go get it and pull it, where that tiny little thing may have been missed by a human. But this is the attention to detail and capability that our robot has and can deliver for you on your lines in your facility. So very simply, we see it, we sort it as, okay, we know that's polypropylene, we kick it out into a bale that keeps your bales pure, you know, that keeps it, we're not guessing, essentially, our robots know what it is, so you're not going to get a blended bale, and then you're going to get pure bales, and that allows you to sell them at higher prices or, you know, not have a problem moving that sort of material. So our vision system, that's the robot side of it. The vision system, this is like the first half of the robot without the big picking arm behind it. So we have people that will drop these in their facilities for a number of different reasons. It'll help them drive, if there's any reporting or anything that they need to do for the counties or for the solid waste districts or whatever, or if they have grant money coming from certain people, then they need to show diversion rates or X amount of material going down the belt. We have these camera systems that can go in and capture all of this. It gives you material composition of what's coming down your belt. So everything on that screen that we showed you previously with the metals, the fibers, the polypropylenes, whatever, all those little boxes have their own classification to them. It will capture all that, upload it to this dashboard called Clarity, and it will allow you to basically see in real time what's going down your belt, so you can make changes if you need to make changes. If you have a new hauler coming in, or you've brought on, you know, a new waste stream, you can see what's in that waste stream. Again, if material's wet today and you're putting it through, and you can see, you know, what is that doing to the facility? Is, you know, am I getting too much fiber through? All of that type of stuff. It gives you real, tangible, hands-on data to make decisions with in your facility, to be more efficient, to be more productive, to capture cleaner material, all of that you've never really had access to before in real time. Up until now, it's been, you know, you have your guys out on the floor and they're looking at it kind of going gut feel, hey, this is what I'm seeing today. And you make decisions based on that. Maybe slow the belt, maybe, you know, speed up the belt, maybe adjust some screens, but it's kind of gut feel. Now we're giving you the capability to have tangible numbers to say, you know, this is what we can do. Where we're also seeing people use our vision systems is, you know, for, you know, waste audits coming in. You can, you know, dump these, run them down a conveyor. We have somebody like running it on a loop conveyor just off the tipping floor. They'll put it in there, run it up the conveyor. They'll get an audit done on it, and they'll basically essentially dump it back down on the tipping floor so that somebody can grab it and throw it into their hopper. And we're also having people starting to use this for like bale purity stuff. If they have a conveyor that's running off the end into a bunker, they can put a vision system at the end of that line, and it's going to track everything that went off the end of that bunker into the bale. So you know exactly what's in that bale, and you can have a report actually saying, hey, here's the purity of what's in there, so that you have some validity and or can, you know, try and sell it overseas and or, you know, try and drive a better price for your bale because you have a report validating what's in there.
Hey, Tim, we had another question come in. It says, what is their percentage of residual per ton, and then what percentage do the humans capture of the material and residual?
Say that again?
So what is their percentage of residual per ton was the first part.
Okay, so like how, so our robots can pick things, you know, accuracy of, you know, 90, 95, 98%. But the amount of, just to say like the amount of residual, hard to say this is what it is, because a lot of it depends on material presentation, belt speed, kind of what we're set to pick and where we're picking it in the facility. What we aim for is, you know, 95, 98% efficiency. Sometimes we're, you know, we can be 98, 99% efficiency. Sometimes we're 90, 92% efficiency. If we have, you know, we have some facilities where the burden depth is super, you know, super thick, and we said, hey, you know what, ideally, you know, the robot can only see what's on top, right? So if you have a water bottle, you know, sitting underneath a piece of cardboard or fiber or something like that, it's not going to grab it. So a lot of the efficiencies of the robot are set by how the presentation is, and that's something that we help with on the front end to say, here's what your material looks like now. You may be running the belt at, you know, 150, you know, feet per minute. We want to try and crank this to, you know, 230, 250, 260 to get that material presentation in such a way where we're going to be the most efficient, most productive in capturing all of that stuff to try and drive that number as high as we can get it.
Awesome.
Now, was there a second half to that question or no? Or does that answer kind of?
Yeah, it said, what percentage do the humans capture of the material and residual? So maybe I'm just assuming that maybe like there still is a need for human, like you were showing in the first video. I'm guessing, you know, there still is a need for sort of like quality.
Yeah, and that's
human interaction.
And again, that's something that we can help assess. You know, if you're looking at this, you know, for instance, you know, if we're looking to put this on a fiber line, and you typically have, you know, 4 people, 6 people on a fiber line, we could put this in, and this could take the place of, you know, 4 of those 6 people, or, you know, all 4 people. But if you're trying to make, you know, super high, you know, news grade paper, maybe you want 1 person there at the end just to pull out, you know, a piece of OCC or something like that went through. So a lot of it depends on what you're trying to make on the back end, you know, where your purity needs to be. If it needs to be absolutely perfect, then, and we're running the belt super fast, then you may need a sorter there. If the belt's running slower because the presentation's okay on a slower belt, that gives the robot more time to make more picks while the material's under the belt, and then you may not need the sorter afterwards. So it's a little bit of, I don't want to, you know, give a cop-out answer and say, you know, it's a little bit case by case, but it is a little bit, depending on the material presentation, how fast we're going to run the belt, how absolutely clean we need the bales, purity-wise, and then we will say, okay, like, here's what we can deliver. You may want a sorter afterwards. You may need a sorter afterwards. You may not need a sorter afterwards. But we give you everything, cards on the table, eyes wide open, and then that way you guys can make your decisions about what you think you need, or, you know, you may start with a sorter there and then go, hey, you know what, I really don't need him there. Let's move someplace else. So that's kind of how we approach it.
Yeah, I see. I think really it just is gonna depend on the facility, how much material you're trying to move through the facility, you know, how specific you're trying to get it to. Because I had a question, you know, like, would you say that your pieces of equipment, the AMP equipment, is more sort of suited for like a curbside where all types of different material, or would you say it would be more well suited for like, you know, just a fiber recycler, or, you know, just plastics?
All of the above. I mean, we have multiple robots in plastic reclaimers, right? Such as, you know, there's a video coming up here from Evergreen out of Ohio. Their PET reclaimer, they just went, you know, public, putting something out there white paper wise saying we help them double their PET capture rate, and all they do is plastic. We also have installed at Midwest Fiber on their fiber lines, and all they're doing is, you know, fiber stuff. So we can do it all, but it's mainly driven off of, yeah, the stuff that goes in your blue bin. So if you're throwing that in your blue bin at home, whether it's cardboard, whether it's plastic bottles, whether it's Amazon bubble wrap packages, whatever, you know, even, you know, plastic bags and stuff like that, we have systems to deal with all of that stuff. So it's kind of case by case, what you're looking to do, where in your facility, and then we say, okay, here's how we're going to build out the solution for that part of your facility.
Thanks.
Yep. So this is that Clarity platform. So with that vision system, whether it's on the front end of your robot or standalone vision system, this will give you exactly what's running down your belt. So you can set your target materials to say, hey, I want to know how much plastic, polypropylene, HD, fiber, whatever, and it will classify it for you in real time, as well as give you, you know, if you have non-target materials, if you pick out everything you want to know and say, you know, assume that everything else, or set everything else as residue, you will see, you know, live stream of, hey, here's my recyclable materials, here's my target materials, non-target materials will show up there in your yellow, and you'll have real-time breakdown by the, by the minute of what's running through your facility. And then that data can then be, chunked out via timestamp, exported to Excel. If you have a new hauler coming in, you can kind of, pair it and start a new read of new material coming through if you want to basically waste audit something. So it gives you a lot of access and ability to really get some data about what's running through your facility as opposed to gut feel, right? And then you can see trends, are we seeing more HD coming through? Are we seeing more polypropylene come through? When we see our commercial stuff, are we seeing more plastic come through in our commercial stuff, or is it, is the plastic disappearing and it's almost all fiber stuff coming through with our commercial loads? So can give you some really powerful information if used the right way to make some very strong decisions about what equipment you're looking to put in your facility, or what may need to be upgraded, or what may need to be serviced. We have the ability within this platform as well to set alarms basically for you and say, hey, listen, if I see more than 10 UBCs a minute at this point in my facility, I know something's wrong. Like, send me a text message. It'll kick you a text message and say, hey, listen, we just saw 12 UBCs. So you can go out or call somebody to go out and see what's going on with your eddy current or whatever is going on, that all of a sudden we're seeing more fiber or more UBCs in certain places. So your facility doesn't run for hours without something, being captured or something being done about it. So it gives you, like I said, real-time data and the ability to kind of set some alarms on some things so that, if something's going wrong or something's getting missed, you don't just lose, hours of material out the door. You can capture that change pretty quickly and then, do something about it. So here's a video. This is Evergreen, and this is less about, watching the robots. You kind of seen that, but there's some voice of the customer in here, Evergreen, kind of speaking to their experience so far with us and what we're doing with them. So yeah, that was a little snapshot of what we do with Evergreen at up their Ohio facility. But I don't know, my internet, some of the audio was a little in and out from me, but I think you got the gist of what he was saying. It's, we put the robots in, they're showing up to work every day for those guys. They're not taking bathroom breaks, they're not taking lunch breaks, they're not taking whatever. And they can actually run the robots at the facility, when nobody's there as well, to just keep running material, which really helps them, again, increase their pick rates and their uptime and just increase their overall performance of their facility. So AMP materials. So we'll go, a little bit quick through this. This is utilizing everything we've talked about so far. This is just a different segment of our business a little bit, but wanted to throw it out there for you guys because it may help you in your facility. Not so much, buying the technology, but this is the part of our business that works to help you kind of offload that residue if there's some recoverable material in it to one of our high diversion, facilities, and basically run that material again at one of our facilities to pull out all the commodities before going to landfill. It also helps you guys, drive down your diversion rates of what's just in the landfill, and can help you guys look good in some of the reporting you do. So go ahead, next slide. So this is one of our facilities. Right now we have 3 of them across the country. We have one in Denver, one operational in Atlanta, and one that's about to come online in Cleveland. So you guys being in Tennessee, kind of centrally located between the Atlanta and the Cleveland facilities. And we have people on I can put you guys in contact, but my counterpart on that side of the business, if it's something you would be interested in, talking about residuals and getting rid of your residuals so that we can capture them. But essentially, this is one of our facilities. We take all that material, push it through, use our AI, to try and find any of that stuff that may have been missed the first time through, capture it, throw it into bunkers, bale it, and get it back out into the circular economy so it can be used again, and then push whatever is truly residue, to the landfill, so we're not losing valuable commodities to the landfill. It's all secondary sort, We're just taking residue material and or mixed plastic bales, your 1 through 7s or your 3 through 7s or things like that. We'll take those two and kind of sort them out for commodities and things of that nature. But we can help you guys on the back end with some of that. Again, not that you have to put in any technology for that. That's just something that our commodities guys and materials guys get in touch with you if there's any interest, but wanted to run that out there for you. Go ahead, next slide. So very simply, pretty quick, we're not a primary capture facility. We're not a MRF. We don't have that type of capability, capacity. But all of that coming from MRFs, coming from producers, coming from whatever, it runs through, gets the first shot. You guys get the vast majority of it. We're just trying to capture whatever we can before going to the landfill so that we're pulling out more of that stuff. The other big benefit to this is our cameras that are running these facilities are also seeing all this material that got missed the first time. And typically it gets missed the first time for a reason, It was hard to classify, either for human sorters or for some sort of automation, whether it's opticals or robots, whether it's our robots, competitive robots, it got missed. And it usually gets missed for a reason. So now it's going back to our facility again. Our robots and cameras essentially are getting a second shot to look at it and qualify it and classify it, which is allowing us to add a lot more of the hard to recover material, or the material that gets missed the first time through, to the database, So again, we're going back to those 10 billion images. Now we're adding a lot of the stuff that typically goes to landfill, a lot of the commodities that typically make it through and go to landfill, we're adding those images back to our database now, so that if it was just something that was too dirty or got missed the first time through for whatever reason, we're being able to classify it, add to the 10 billion, so that hopefully next time it comes through the facility the first time, we're able to capture it, because now we're adding all of this hard to capture material data to our database as well, not just the, I don't want to call it clean, but the first time through easy recoverables. The stuff that gets missed for a reason, and now we're giving ourselves a chance to capture, classify, and add that knowledge back into our growing AI, so that that AI gets to a point where hopefully, we're capturing all that stuff first time through and not missing it. So same thing here, talking about just economical, benefits to all of this. I think you guys all get it coming from the industry, right? Anytime we can divert stuff from landfill, push more recyclables back into the economy, better for the world, better for this, circular recyclable economy that we're all trying to drive here. Creating more feedstock, all of that type of stuff. So again, we've talked about this a couple times. This is how our brain, our amp neuron sees things from our eyes, our vision system. So it all goes through in real time as fast as that belt is moving. Big one here to take note of is, almost center of the screen black plastic, right? So a lot of times with opticals and things like that, we have a couple of them there. We have a cup and we have what looks to be like some sort of thermoform black plastic there. Big thing with AI versus near-infrared is near-infrared really struggles with black plastics. We can see those, we can classify those, we can capture those. So it's, another advantage to AI versus some of the other things that are out there. So that's, all in all, we are driving technology to an industry where we think it can really help drive, economic growth, financial growth for the industry, making it more beneficial for people to recycle. If it's more beneficial for people to recycle, we hope that they will want to recycle, right? And if it becomes more financially beneficial to recycle, we can start to expand recycling and make it, scales into more of a government and policy thing as well at that point. So, but we got to start somewhere. So we're here trying to put technology into the industry that makes it easier for people to capture what they're supposed to capture at a lower cost, so that everybody can make a little bit more money doing it, get a little bit more excited about it, and hopefully, have some policy and stuff that starts driving it and assisting with making this more successful. That's what I got, guys. Thank you so much for your time today. I know we're set for an hour, right up against it, but happy to take any sort of questions that may be there or, that may have come up since last time we answered questions.
Yeah, we had one come in a little bit ago. It says, can Tim talk about using the system in a pre-sort capacity to remove potentially dangerous materials such as lithium batteries that may cause fire?
Yes. So the issue with robot on pre-sort is, again, the robot can only see one layer deep, right? So typically pre-sort is, burden depth is a concern, right? And that's why things get missed, occasionally in pre-sort. You get lithium-ion battery, it makes it through, gets compressed, and now we get a fire or something like that. So we have some people playing with the vision system because our vision system can recognize hazards. We classify them as hazards, right? Lithium-ion batteries, propane tanks, sharps, that type of thing. But with regards to the robot picking them, harder to do on pre-sort just because of the burden depth, and then same thing with the vision. It's harder to see all of them because it may be under paper or whatever. So the pre-sort application is tough just due to the fact of you gotta be able to see it, right? And usually burden depth on pre-sort, when it comes to heavy things like lithium-ion batteries, those are usually falling onto the belt, and then you have something lighter, cardboard, paper, fiber, whatever, that ends up sitting on top of it, and then we wouldn't be able to see it with the robot or the vision system. So if the pre-sort burden depth is singular, if you will, we could look at it, and that's where, there are a handful of places where they're really not doing much volume, much smaller MRFs. They're not doing much volume, so their belts are running much slower. Their metering belts are running much slower, so that pre-sort is, the burden depth is pretty singular, and that's where we're looking at this vision system where it's going to see everything going, and if it sees a lithium-ion battery or propane tank or sharps or things like that, right, it's set up for those alerts we talked about through Clarity, and it'll ping somebody, and they can pull an e-stop and go find it and say, okay, we need to pull that out. So it can be done. We're starting to explore that. Our vision system has the labels to recognize and categorize those things, but again, it's making sure that the application is correct and or we can get it dialed into the point of being able to see things in such a way that it's going to be beneficial to you and make a difference and help drive that safety. There's also we have a couple of customers thinking about putting them, you know, right in front of their baler, same type of thought, right, to catch anything that may go in the baler, get compressed and start a fire. But again, same thing, material going into a baler is typically, you know, not singular and burden depth either. So same kind of challenge on that baler feed as we're seeing pre-sort is we can absolutely do it, but we can only see the top layer. So if something's hiding under something, then we can't see through objects to make sure that everything is clear underneath.
Yeah, thanks, Tim. And that same person said, can the vision system be installed on a vertical fall then to catch batteries or other things dropping?
I don't think we can catch them in air dropping. I mean, the vision system can be installed on any sort of incline, flat, whatever. But I don't think that's a really good question. I don't think we've ever had anybody ask that. I can double check and get back to you, Caleb, with an answer, right? And you can spin that back to somebody. But I'm pretty sure it has to be. We have to be reading something off a belt. I don't think we can capture something mid-air, kind of free fall, falling through the vision system. I don't think we can do that, but I can definitely double check and get an answer back to you.
Yeah, maybe that's the next step for the next AMP robotics tool. Well, Tim, thank you so much. The knowledge that you brought about what you guys have going on at AMP Robotics is really a breath of fresh air. It's good. It's really exciting for me to hear about new technology like this. You know, when you go into some of these MRFs and stuff and you see their old lines not being used anymore just because it's hard to get people to work or you know, just is not as efficient as it could be. And so being able to see new technology like this and what you guys got going on is very exciting. I wanted to let everyone know that this has been recorded and will be put on our website, on the TRC website. We plan on having more of these virtual webinars throughout the year, so stay tuned and be on the lookout for registration links and webinar invitations. The presentation and the recording, like I said, will be sent out in a follow-up, and maybe if you have any more questions that you didn't get to ask or you come up a little bit later after you're thinking about the presentation that we heard today, send those my way. My email is caleb.powell@tn.gov. And then whenever I send out the follow-up email, if there's any questions that we got, Tim and I will work on getting those answered, and then all of that sent out. Tim, once again, thanks again for all your work and doing this presentation for us, and we hope everybody has a great week.
Thanks, guys.